Hi, this is Jose Luis, and welcome to a new exercise in this series of Introduction to Parametric Modeling, where I'm going to teach you how to model a very simple drinking glass. Okay, but the beauty of this is that it's going to be fully parametric. So we're going to be able to choose, for example, the point of where the center is going to be, but at the same time, we're going to be able to choose a few other parameters, such as, for example, the radius of the base, how tall or how short the glass is going to be, and the inclination of this glass. And by doing this, we will be able to choose and explore all the variability of different forms so that we can then generate different versions, bake them, and then send them for rendering, for fabrication, for production, whatever you want. Okay? Now, this is going to be a super simple exercise. We're going to learn the basics of numerical relationships between point coordinates. It's going to be super interesting. And yeah, let's get busy. Let's get doing it. Let's get hands-on. Let's get busy. So as I said before in my previous video, the best way to start any parametric modeling exercise or work is to break down the problem into the steps that we think we're going to pursue in order to complete the exercise, and also think about what are the inputs between what are the inputs that we're going to be using and what is the relationship between them. So what I want to do is I want to, in general, get some kind of shape that is going to look something like this. It's going to be a vase. It's going to be a drinking glass. All right. And if that's what I want to get to, I think that in general, a good way to get to this form will be perhaps to first model something that looks like the profile of the vase, something like this, and then by a simple process of revolution, if I revolve that shape in 360 degrees, I can probably get the surface that generates that drinking vase, that drinking glass, right? So then the problem is reduced to figuring out how to create parametrically the shape of the glass, the profile. Okay? If that's the case, then I can think of a few things that we can take a look at. So that we can use as inputs. So for example, first of all, probably the input that I want for this glass is going to be this point here. I want to start from the center of the glass, okay? The center of the bottom. Then something that I will want to also have control over might be the radius of the base. So I may want to have control of this distance, and therefore there might be another point here, and this is going to be the radius of the base. I'm going to call this capital R, the radius. And then this could have some kind of other point here, a third point, all right? And then this point could be the point that closes the polyline that becomes the curve that I want to revolve. And then there would be an axis here that I would do the revolution over. My question here would be, what parameters am I going to use to control where this point is in 3D space? You could argue, well, maybe I can use this radius here. But I would argue that perhaps that is not very intuitive, because if I do that, if I have, let's say, one slider for the radius on the bottom and another slider for the radius on the top, if I have two sliders, then maybe what would happen is that as I increase this radius, I would start getting a shape something like this, which would basically kind of break the inclination that I have already achieved in my glass. So from a design perspective, I don't think I would want to do that. So another thing that I could choose is, well, maybe I want to control this angle here, and that's going to be the parameter. And then I want to control that angle and maybe this distance here, inclined. Turns out that I, as a human, personally, I have a rough time getting a sense of how much 72 degrees is, and also having a rough time about like how much an inclined distance is. I'm much better at vertical distances and I'm much better at horizontal distances. So what I'm going to do, and this is my choice as a computational designer, there's no right or wrong here, and it depends on many aspects. What I'm going to choose is to, in my case, I'm going to choose to use this other distance. So from here to there, so I'm going to call this B. I'm going to choose that additional distance to be what I control about the point, and then this vertical distance, H, to be what I control about the other point. So that if at some point I have decided that I like a particular height and a particular distance that generates an inclination of the base, then anytime I change the radius will get larger, but the inclination will remain the same. And therefore, I will have a better control over the parametric relationships of this base. Again, this is just me as a designer, and I choosing what do I want to control. There is no right or wrong here, and we can all have an opinion on which maybe you think that a different application is better. Or maybe if you are designing this for the perfect stacking and packing, whatever, and some kind of optimization, then maybe you want to choose the angle. It's up to you, okay? So I think for me, the radius, the horizontal inclination, and the height are going to be the parameters that I'm going to use to model this face, okay? And then the process is going to be as simple as first, and also the center of the glass. So I'm going to take this center, that's going to be an input parameter, and then I'm going to calculate, if this is 0.0, I'm going to calculate 0.1, and then I'm going to calculate 0.2 based on the relation of this point and these other three parameters. I'm going to trace a polyline, and then I'm going to revolve that in 360 degrees. And that's going to be my drinking glass. It's going to be super simple, okay? Let's take a look at how to do that with actual code in Grasshopper. Let's get started. The first thing that we said we wanted to use as input parameters was going to be the center of the class. Remember that that is a point. So remember that there's two ways we can go about this. One is we can just generate the point with XYZ coordinates in Grasshopper, or we can create a physical point in Rhino and then bring it into Grasshopper. So for the sake of explaining some other techniques, I'm actually going to do that. I'm just going to place a point here. I'm going to right click here, take point, and then just right click and set one point and input that here. And for those of you who don't use icons, I'm just going to place here bifocals. Okay, so I have this point here, and which is going to be the center of the class. And then I'm going to add a few more parameters. So I'm going to add a new parameter that is going to be a slider, and it's going to be, I'm going to call this capital R. And remember, as per our diagram, that's going to be the radius of the base of the glass. So this is going to be a slider that is going to go from 0 to, for example, 10 units, for example. And I'm going to set this at the value of 1 right now. So that's going to be one parameter. Then the next parameter that I'm going to throw in is going to be another slider. And that slider is going to be lowercase b, which is going to be the horizontal offset from this point to this point, how far they are away horizontally. Okay, the way I'm going to do that is I'm just going to right click here and say B, and then I'm going to edit this, and I'm going to say, well, this is going to be from -5, because it could go inwards. Maybe we want to design a glass that can bend inwards, but if we don't, we can actually cap that possibility by just saying that the minimum of this slider is going to be 0. And then the maximum is going to be +5, for example. And I'm going to leave it at the value of 0.25. That's good with me. And then I'm going to just copy paste this one and then say that this slider now is going to be H, and it's going to be the height of the glass from 0 to 10, just like the previous slider. I'm going to align things up, group things, whatever, and now I have my inputs. Correct. So this is great. So now I am ready. These are the inputs that I want to use for my definition. And now the only thing that I need to do is I need to find, I already have point number 0, the one at the center. I need to find point number 1 and point number 2. How do I do that? Well, turns out that the relation between the 3 points in terms of coordinates is actually very clear, because if you think about this, if this point has x, y, and z coordinates, whatever those are, if we think that this vase, this glass, is something like this, so this is x and y and z, it turns out that whatever this point is going to have the x coordinate of this point is going to be whatever the x coordinate of the point at the center was, plus the radius. Correct? And then the other two coordinates, y and z, are going to be the same. So in order to find point number 1, the only thing that I need to do is I need to figure out these coordinates and create a new point where the x coordinate has the radius added to it. So let's just do that. So how do I go now about, I have the point that has been referenced here, and I can see that that point, I can't really read the coordinates here, but it has whatever x, y, z coordinates. How can I read those coordinates, the x, y, z, and then add some number r to the x? Well, it's actually quite easy. So if I go to the vector tab, and if I go to point, you can see that we have used the construct point. Given 3 numbers, I can create a point object. But it turns out that there's the exact inverse component. Given a point, give me the 3 numbers that define their coordinates. So I'm going to place this one, deconstruct, takes a point here, and now I can see the x value, the y value, and the z value. All right, so then point number 1 is just going to be as easy as saying, I'm going to add to the x coordinate, I'm going to add the radius. And now I'm going to create a new point that is going to be the x coordinate is going to be the x coordinate of the previous one plus the radius. And then the y coordinate is going to be the same, and the z coordinate is going to be the same. You see what's happening here? And now, no matter where I move the original point, the other second point follows parametrically. And if I increase the radius, you can see that the other point is just always bound. So this is going to be, I'm going to call this point 1. Okay? How about that? I know that I've always said that I like expression components better, but I mean, I also use operator components here and there. Okay? There's nothing written in stone here in parametric modeling. Now, the thing that I need to do is I need to find the point number 2, the one on the top. And then if I think about it, it turns out that the coordinates of this point, x, are going to be whatever the x coordinate of point number 1 plus b. And then, so because whatever these coordinates are, plus this distance. Now, the y coordinate is going to be the same as in y1, because remember, there is no depth here. It's not going anywhere deep. But the z coordinate is going to be whatever the z coordinate of number 1 was, plus the height. So this value here. So the only thing that we need to do is now break down those relationships, take the coordinates of point 1, and use those to generate point number 2. So let's do that then. So I'm going to go back here and say, I have the coordinates, I have point 1 here. So I could either say, well, I'm going to deconstruct this point again, x, y, z, and I'm going to operate with this. Or I could, if I wanted to be a little bit more optimal, just fetch them directly from here. I know that this is the coordinate of x1, and I know that these are the coordinates of y1 and z1, because that's what I'm using here. But For the sake of visual, I'm just going to do this. It's not the most optimal. I'm doing extra operations, but it's fine. So I'm going to take this, the coordinate of 1, and for x, I'm going to say, for this, I'm going to add b. Y is going to be the same. And for z, I'm going to add the z coordinate, I'm going to add the height. And then now, I'm going to construct a point with the new x, the same y, and a new z. And if you look at that, and if you look at this is going to be point number 2. Let's see if this works. I can increase the radius a lot. If I increase the radius, and you can see how the whole wall moves accordingly. I can do negative and positive, and I can increase the height here a lot. So let's do this a little bigger. So this is going to be this, and this is going to be the radius. Okay, and then I have the 3 points now. I have first point, second point, and third point. Can I join those with a polyline? So let's do that. So I'm going to type here polyline, and I'm going to add the first point, the second point with the shift, and the third point with the shift. And now I have created the wall for my drinking glass. And I'm going to give it a little bit more of an inclination. Okie dokie. Wonderful. So we have now the wall. Now the only thing that we need to do is we just need to create a vertical axis, and we need to revolve this curve around that axis to generate a surface of revolution. How can we do that? If we go here to the surface tab, and if we go to freeform, you can see that somewhere, where is it? Revolution. We can create a surface of revolution. Let's drop this and see what parameters does it need. So I'm going to need a profile curve. I'm going to need a revolution axis, and you can see that the icon tells me that it has to be a line. And then this is asking me the domain of the revolution. So from 0, and you can see that by default I have from 0 to 2 pi. 2 pi in radians is 360 degrees. Okie dokie. So let's take that. I'm going to fit here the curve. And then for the revolution axis, I actually need a line. Okay? So turns out that, do I have a line? Do I have anywhere this line, the line that I need to use in order to revolve the surface? I don't have it. So I may, just for the sake of temporary geometry, I may need to generate that so that I can feed that data to the component. How am I going to do that? Well, I can just generate a line that is going to be this point, and between that point and another point that is any distance on top of it. It doesn't really matter. So what I'm going to do is I'm going to take, for example, I'm going to take this component. I'm going to take this point. I'm going to deconstruct it here to the z-axis, to the z coordinate. I'm just going to add some random numbers. So I'm going to create a panel, and I'm going to just use 1 as a unit. This is not even going to be a slider, because I don't want to have the user think that this is something that they should, oh, sorry, I'm not sharing, sorry. So I'm going to take the original point, I'm going to deconstruct it in coordinates, I'm going to add the z height. To the z height, I'm going to add 1 unit, and then I'm going to construct another point based on the same x, the same y, but a z coordinate that is a little higher. Okay? And then what I'm going to do is I'm going to create a line object between the second point that I generated and the first point, the original one. So now you can see that I have this line that is a vertical axis, and no matter where I move my point, all the other 4 points are parametrically linked to it, which is kind of nice. So I'm going to use this line as the revolution axis, and ta-da! Woohoo! What do we have here? Oh my God, it looks like a drinking glass, but I don't like the proportions here. Wait. So let me make this a little more and a little more slender. I kind of like this. What about this? This is looking kind of nice. Do I like this? I don't know. Let me see. I'm going to bake this so that I can see a little better. Okay, and I'm going to choose ghosted so that I can see. Let me try another one. So I'm going to move the point here. I'm going to bake, and I'm going to make a version of this that is going to be a little wider, perhaps a little more ample, and a little thinner. Okay, so I'm going to bake that one, take a look at it, and then I'm just going to copy another one. And now I'm going to make, well, maybe this could be a plate instead. If I just make it like very, very shallow. Wait. Interesting. So it could be a glass, but it could also be a plate. Wait. And then I'm just going to bake this and boom. And this that you're seeing here is what's very nice about parametric modeling. The idea that by creating the tree of relationships that define a particular family of forms, then by modifying the input parameters, like where the glass is the center of the glass, and some numbers that define its parameters, its height, the width, etc., then I can explore the family of possibilities that this gives me, okay, in a parametric way. So in this exercise, we have seen how to generate something that looks like a drinking glass, or maybe actually even a plate, okay? And one thing that I would like to notice is that when I created this point and when I created this line, since this was kind of temporary geometry that I needed just for the process, but it wasn't really meaningful in my definition, maybe something that I want to do is just, I want to hide it. So I'm pressing Ctrl Q to disable the visualization so that in terms of the model, it doesn't obstrude what I'm seeing as the process. Just something to think of to keep your definition a little cleaner. Okay, you could also choose to just delete everything else, all the points, all the polylines, and then just keep it like super simple. You know, I don't know, up to you. All right. Okay, so with this, I think that was a good exercise, and now you can just use your glass generating algorithmic definition to generate a whole variety of these elements, bake them, render them, 3D print them, or whatever you want. Okay, let's take a look at more exercises. All right, I'll see you in the next video, and in the meantime, if you like what you saw, maybe like the video, subscribe to the channel, etc. Thanks a lot, and see you in the next video.